This is a quick run through of the building and really our experience in delivering in the context of current legislation, the budget constraints that we had on the project, the time constraints we had on the project, and also some of the constraints we had working with the university, not just the faculty itself, but obviously the estates team as well, and some of the issues that arise from there. So I'll just do a quick run through. These are a number of things. I felt it was worthwhile just doing a quick run through the whole process so we could touch on some of the issues. I won't labour the point on too many of these, and then at the end I've got some lessons learned that we're taking across into commercial office developments I felt were worth touching on, and some future thoughts as well. So Richard's actually covered some of what I was going to be talking about, which has given us a good intro into this particular talk. And really the context, obviously this is a building for the Faculty of the Environment and Technology. There's a lot of students here, and as well as housing the Department for Planning and Architecture, it was going to house the Product Design School as well. So a slight twist upon the types of students that were going to be using the space. The site, Richard's talked about that to some extent, but really that sort of context that we were dealing with, the mixture of buildings on the campus itself, the poor quality of some of the external environment, and some of that disjointedness that exists on the campus as well. And clearly you can see that context having changed significantly during the time that the first phase was built, with all the student resi running around the site. As Richard said, there are a number of key elements with the first building that were trying to push the boundaries of sustainability at the time, and that was looking at rainwater harvesting, natural vent, passive cooling, the cladding systems as well, looking at ways in which we can clad buildings in a different manner, looking at straw bale cladding on this building, looking at the tile cladding as well that was used on the first phase building that got the university onto tomorrow's world at the time as well. So it was really trying to understand the context that we were working in. The PVs came at a later date to the building, and also this automatic nighttime purge ventilation as well. So clearly the first phase building was already pushing its boundaries back in 2002, and what we wanted to do was see where we could then go with that. There's a couple of sections through the existing building, just showing that atrium space that Richard was describing earlier, and that very, very simple plan, with a staircase at each end of that atrium space, light coming down into that central atrium, and then the bridge link coming through into the building. One of the key things really was how you enter into that existing building and how we wanted to develop that as well. So I'll talk about that in a moment. So this just takes you up through those floor plans, and you can see that connection back through to the ground floor plan, and then the connection from the upper levels down through the atrium space as well into that large common area. So just a little bit about our appointment and why we ended up building or designing the second phase building. There's an OG process for any publicly funded projects, as most people in this room know. The university has a framework of architects. We're one of 7 architects on the framework. White Design are not one of those architects. It went out to a mini tender bid to all 7 architects. We responded to that with a team built up of consultants from the framework. We then submitted a proposal for that, and then attended an interview, and then were successful getting through to that final stage. We were then appointed via various different forms, but that was really via the main framework, and the university uses the Scala form of appointment, which again is very specific about the types of services that they were looking for from us. Just coming onto the brief, the original client brief was very much about a replication of the existing building across to the site when we first bid for the project. As we got into the initial discussions with Richard and the rest of the faculty team, it became clear that it wasn't just a building for the School of Architecture, it was also going to include product design. There are requirements for a lecture space, there are requirements for a cafe area. We started looking at some of the briefing issues as well about how the building could be knitted into the landscape, and that in itself then started to generate a change in brief really, and started to develop some of those key issues. And really it was trying to pinpoint some of those key issues about the energy and water strategy, trying to use the principles of lean, clean and efficient, looking at opportunities to push new technologies as well, things that the university hadn't used before that maybe could be used on future developments on the campus, and also looking at the opportunity to use different materials on the building. So again, there could be this compare-contrast aspect. And then there was also this aspect of the ability to learn through the building. Richard was very keen, as were most of the faculty at the time, to see whether we could actually construct the building out of a different frame solution. So maybe this could be a concrete frame, compare-contrast to the steel frame next door. Various reasons why that couldn't happen, but there were other opportunities for us to test some of those principles. And really that ability to learn through the building was going to be key, and creating this learning living room area where more informal teaching and learning could take place. And also this principle of what you see is what you get. Really, really stripped down building finishes throughout. So again, it's very clear how the building's constructed, how the building's ventilated, and how the services work. Clearly, from 2002 to when we started designing this building 2 years ago, the legislation context has changed significantly. Partel has moved on a couple of iterations. BREEAM has come into much greater prominence. The EPCs have come about, and RAP as well, in terms of the recycling aspect of that has risen in prominence as well. Maybe not to such an extent as the other issues have, but it's still something the university at an estates level were very, very keen to look into and understand what that would mean. So just briefly onto the site analysis. I think an awful lot of this we've covered already, but as Richard said earlier, the context changed really from when the original building was opened to when we came to the table to start looking at the design, looking at those connections across the campus, and really starting to look at ways in which we could address the entrance to the building as well. When the building was originally designed, it was very much seen as an extension to Q Block, and that entrance from Q Block coming through the bridge link in at first floor level. During the conversations with various other people in the university that used the building, they felt that the existing R Block was a little bit difficult to enter without feeling like you were straying into territory that wasn't your own. And part of that, I think, was coming across that bridge and landing in a new facility. And so really we wanted to look at a way of integrating the building within the landscape to a greater extent, and looking at using these footpaths as well that go up the side of Q Block to a much greater extent. That obviously drove us on to starting to look at the building orientation and how that building would work, and how the connections between the new building and the existing building would work. What were the opportunities there? And really we were looking at this opportunity to create a new south-facing plaza for the students, not just for this facility, but for other users around the facility as well, and this glazed link between the two buildings that would then allow a route through from the student resi through into the plaza, and then up some steps and then back along into the rest of the campus, trying to knit together the building into the rest of the campus. So just very quickly, I'll go through the key stages of development for us really. There's a number of iterations that we went through really, looking at the different format. The studio proportions and principles had really been well established on the first phase. Justin will talk a lot more in the M&E session on this about some of the principles, but at a very early stage we were really starting to look at how could we ventilate this building, how could we heat this building, what technologies could we start employing. And you can see from the section we were starting to look at whether ceiling roofs were appropriate, how the ventilation strategy worked, could we pull in a ground ducted ventilation system, was there a way in combining some ground source heating scenarios with the building, as well as starting to look at how the building configured as well. So that was at stage B. Stage C, our thoughts then moved on. We started looking at the glazed link in more detail, really starting to rationalise those studio spaces and that breakout space, and looking at this natural ventilation principle. The building is slightly different in the sense that there's a much higher IT use in this new building than there was in the original building, and some of the spaces in the original building were starting to suffer from possibly greater IT use that was causing some overheating. So again, the strategies were starting to look at a development on from the existing building. And that was really at stage C. And then at stage D, prior to planning, the section had really firmed up. You could see that really between the stages we were looking at something a little bit more different to the original building, but as we progressed through the design, the section that exists on the existing building started to make an awful lot of sense, but things were tweaked. The balcony levels were tweaked. The clear story glazing was tweaked. The night purging doesn't occur in this building in quite the same way. So there are a number of subtle differences that occurred. And you can see on the perspective view up at the top there that that's pretty much getting close to the building that we have today. And then the planning scheme, just running through that, this connection back into the landscape, how landscape architects worked with us very closely. By this point, we'd been appointed onto the project to actually define the master plan for the university as well for the next 10, 20 years, looking at integration of the HP site. So we were starting to look at a much, much wider context as to how this building sat into the landscape and how that connected back into existing pathways. And then starting to look at the design in more detail, how the learning living room grew from something that essentially was a table with a coffee machine through to something that you see today, which is a much more defined cafe food offer and a breakout space there as well. I won't go into detail in the plan because we're going to do a tour around the building shortly, and if there's any questions then we can pick those up. So simply speaking, there are a range of studio spaces around a very similar atrium space. There isn't the connection between the first floor and the ground floor that there is in the existing, primarily because we have a cafe space on the ground floor and we wanted to use the layering of the building to allow us to create those levels of privacy as you go up through the building. So the ground floor is very much a space used for the whole university, and then as you move up through the building it becomes far more faculty specific. So when you get up to the top floor, we then have staff offices which are open plan, so we have around about 20 academics sharing one large open plan office area, and then we have the two postgrad studios for the School of Architecture as well. And then the section you can see there, very simplistically, working in a similar way to the existing building, but slightly more generous balcony areas, and we have our lovely dip down onto the lecture theatre, and I'll explain that a little bit later. And then our elevations, I'll come on to the makeup of the facades and the components we've used through the building in a moment, but you can see that's pretty much the building that we have today. And the rear elevation, good example of how things moved on really, looking at slightly different elevational treatment to the existing building as well, and pulling through these chimneys, looking at that natural ventilation, trying to push that harder this time in this second phase building because of the higher IT use within the facility. And then some of the final images that we use for the planning application. So sustainability and energy efficiency. I won't dwell on this because Justin's going to be talking about this in more detail, but needless to say, those four principles were really used throughout the process, and it was very much a stepping stone process to drive down to the solutions that we achieved. And that then informed some of the building fabric. And again, I won't dwell on these, but the principle of having some grills at low level that would pull in the fresh air past the radiators, and then the opening windows, giving that degree of occupant control and BMS automation as well, and trying to get that balance right. And that then in turn had an impact upon the internal environment as well with those teaching spaces. And then also then looking at the way that the ground ducted ventilation system worked and how that was expressed architecturally. At an early stage, we had a much greater array of chimneys, but again, as the technical process worked through, when we came to site, it became apparent that the solution that had been developed wasn't necessarily going to be the most efficient, and therefore that evolved. And really, one of the key things has been that constant evolution, even when we're on site with some of these new technologies, that the so-called experts with the ground ducted ventilation system were not actually that expert. And it was really starting to work through with those guys to try and develop that technology to the point where it was going to deliver what it needed to. And there's some images there of the ducted ventilation system going into the building, and clearly you can see it operating in here at the moment. Our chimneys, again, looking at that architectural expression of those elements that are ventilating the building and pulling those up through the building and having that very clearly identified in the internal environment as well, so the students are very clear about what each of those components is actually doing, and starting to look at how those are expressed on the internal environment as well in the teaching spaces. So I felt it was worth just pausing really on materials, components and the measurement aspect as well. We spent a lot of time looking at these issues, and really that runs down this whole list of various different assessment methods and potential conflicts that exist with that, and starting to look at how we were going to deliver this building within that context. So really it was looking at RAP, the life cycle assessments, the cost assessments, the green guide rating, which is so critical to the BREEAM assessment, the embodied energy of the building itself, the responsible sourcing aspect that was referred to earlier, the maintenance aspects that estates were always very, very hot on, wanting to know what the maintenance regime was for particular elements of the building, and then the target setting. And then this need to achieve the RAP requirements, which specifically related to the recycled content of components. The university were keen to look at that in more detail as a trial on this particular building. And that led us on to looking at the reduce, the recycle and the reuse aspects of the project as well. And one of the tools that we used really was starting to look at the different materials that we could use within this facility to clad the building, finish the building, whether that was flooring, whether it was external cladding. There's a whole series of sheets that really started to look through those issues. And then we started playing that back into the equation with the QS, looking at the costing implications of some of these different choices. And it was everything from comparing cellulose through to mineral insulation, and looking at the sort of the pluses and the minuses associated with that, and where the green guide rating sits as well. And it's not always that the most sustainable product is actually going to give you the best rating for the BREEAM, and there's a constant balance to be had there. So in terms of the recycled, the use of recycled materials, the UE Estates team set a target of 10% of the total value of materials used should derive from recycled and reused content. And that was throughout the entire building. So that then set us a very clear challenge through the process to set some targets and to start looking at materials that could achieve some of those benchmarks. One of the most important elements for us was the cladding. And we spent a lot of time looking at the cladding, different options, be it timber through to brick cladding, through to metal cladding, you name it. We looked at rubber, recycled rubber. We pretty much explored most options, and it was really through discussions with Ibstock, because they had supplied the cladding to the first building, that we wanted to explore things further. And we came up with this product, which is actually I'll just flick back to that, which is actually a recycled tile. So what this uses is slate dust and brick dust from the factory floor at Ibstock, and then that's reused and then put into a tile format and then fired. And the variety that we achieved on our elevation with the different colours was through the firing process. So what we have on the final elevations of the building are 4 different colours, and those are achieved just through different periods of time for firing the tiles themselves. Now, what this achieved was a 94.7% recycled content for the tile, which was fantastic. But clearly, when we talk about low carbon, there is a carbon issue with the sense that we've had to fire those tiles. We have reused a material, but again, looking at the carbon issues, we've achieved it on one hand, but again, there is a firing process to be balanced into that. The steel frame, we actually achieved an 80% recycled content on the steel frame for the building. The aggregate, 100% recycled content. The blockwork I'll come on to in a moment, and the flooring, 37%. So they're just a snapshot of some of the areas that we looked at. And then the final score that we achieved on the building with the main contractor was 21.88%. So we set ourselves a higher target from the outset, didn't really share that with the rest of the estates team. We wanted to keep that to ourselves until we knew it could be achieved. But we set that benchmark with Wilmot Dixon to try and actually push that target higher. And just going through some of those key materials, the recycled cladding was a key element of that. That was the first time it had been used in this country, and is now a product that is marketed by Ibstock. There were issues with the installation of that in terms of the alignment of the tiles and the torque settings with the fixings at the back. So it was a learning curve again for not only the university, but also the guys installing the product and for Ibstock. So Ibstock spent a long time down on the site. Recycled blockwork, is a big issue. The more we looked into it, the more we realised that it wasn't a straightforward matter of just picking the block with the highest recycled content. The higher the recycled content, the rougher the finish of the block. Therefore, chances are you're going to have to plaster that particular block, and suddenly you get into the embedded energy of plastering and finishing that, and the additional trades and the additional costs of that. So again, getting that balance right. The blocks we used had 80% recycled content, so that allowed us to have a paint grade block. We could get up to a much higher percentage of recycled content, but it would have meant we would have been plastering that. And clearly the durability, the robustness, the acoustic requirements of that were absolutely key. And when we walk around, you'll see there's a boxing detail up at high level that deals with the acoustic, something that didn't exist in the Phase 1 building, and again, a lesson learned in the Phase 2 building. The insulation, the warm cell insulation, again, 100% recycled newspaper, but again, there were lots of debates about what chemicals were being used within that warm cell. Was there any particular issues with that? And again, there was a lot of debate about how that was going to work and the installation process. As it is, it worked very well on the building, and that's what we have in the majority of the envelope. Just a couple of images of the block work. Again, concerns often on education projects where block work's being used. But again, all of those images are showing exposed block work, just painted up in a colour that starts to bring the interiors to life. And again, down on the main circulation corridors there. Recycled aggregate, I've mentioned that. And one of the key issues with that is using that in a local, from a local context as well. To achieve the BREEAM points on some of these credits, you need to have that actually achieved from a very, very small radius within the site confines. So again, that's one of the key components that starts to set really your parameters, trying to use the local materials, and to some extent, it's what's available at that particular time. Reduce using renewable materials. The mod cell straw bale cladding had been used on the Phase 1 building, and there was I think it's fair to say, a desire right from the outset to see whether we could use it in some way on the Phase 2 building, as really it had been born out of the Phase 1 building. We spent a lot of time looking at the options, whether we could clad the whole building in this, but really the nature of the studio arrangements, the nature of the fenestration arrangements we were looking at really wasn't going to work particularly well with the mod cell around the main studio building. But in this environment, in the lecture theatre, which was deemed to be a black box environment, it worked very, very well. So what we have cladding around us at the moment is the mod cell panel, which clearly achieves a number of things, particularly in terms of those CO2 emissions. But what it doesn't allow us to do is to get any benefit within our RAP or within our BREEAM ratings. So whilst we have a product that by its nature is reasonably sustainable, it doesn't actually contribute to any of the measurements or any of the assessments that we were using to assess this building with. Just a couple of details. This was a slightly different mod cell panel to that was used on the original building. This was the mod cell light, which actually has layers of straw board on either side, and then in here we're then finished off with our pin board and then our lime render on the outside. So it's really an evolution of what was used on the first building. And again, the original intention was that this was very much going to be a modular solution, that we would cut down on waste, we would have all our modular panels coming to site. The reality of that was that we probably only had 2 or 3 panels that were absolutely alike. By the time we'd taken into account the cutouts for the ventilation system, arrangements with the steel, arrangements with fire exit doors, with storage, with openings through into the main building, and coordination with the steel frame, it then meant that we didn't have that many modular panels. The beauty of straw, of course, though, is that it's very easy to cut down to those sizes, and the same is true with the timber as well. So the level of wastage was relatively small, but it goes to show again that unless you're designing these things in right from the outset as an absolute system, then you're not necessarily going to get the absolute full benefit. These are some photos of the installation process. This was all done very locally, just up at Fayland, across the Clifton Suspension Bridge. We conducted a number of visits there, took some of our students from the office, a lot of our UE students came up with us as well, got involved in the process, and again we were recording the process as the panels were brought to site on the back of the trailer with the tractor pulling that. So again, the process of pulling that to site again, reducing that carbon footprint, reducing the time that it takes to pull those materials in. And a few finished shots. Again, in the cafe there, we have the panel exposing that and then the lime render on the outside. So then moving on to reuse, we really wanted to explore opportunities to reuse a material that had been used somewhere before. And the cafe pod gave us that opportunity. We spent a lot of time looking at how the cafe pod in its own right would act as a piece of furniture sat within the building. And then what opportunities could we use to get student work involved in this? And could we get a material? What we decided was to use a timber. And it's actually a timber from a cheese factory in Somerset that had been reclaimed timber, and then we've reused that to clad the cafe. We did talk at one time about leaving it unsanded, where you can still see the cheese markings, and had various different discussions about how that would work, but we decided to actually clean the timber up, sand it down, and install it. And again, as you walk around, you'll see there are a number of issues with that in terms of the movement of that timber. Gaps are opening up. We had issues with the subcontractor. The subcontractor that was building this went bust partway through the process, and there were a number of challenges that arose as we went through the design process. So again, not without its issues, but again, we wanted to trial this and look at what the implications of that were. Once again, none of that could be used in any of the assessments that we were assessing the building upon, but it was a worthwhile exercise that we felt worth testing. And that was before the timber started its lovely shrinkage. And then this is the front elevation. Again, a few issues with this. The final execution of the detail by the subcontractor wasn't quite what we'd originally envisaged, but in essence what we were trying to achieve here was get either some student work or get something into the design of the building here that started to have some resonance with Bristol and with the university. And this was a plan of Bristol done very much in the style of the Nolly plans that was then laser cut into the screen themselves. So just then very quickly going through, the next process obviously was that contractor appointment within the sequence. The university were open to different ways of undertaking this project, whether it meant us being novated or not. As it was, we were novated to the main contractor. We took the design up to a sort of an E+ level of detail, so we really did define everything to quite a high level and specified everything to a high level. So there really wasn't very much opportunity for the contractors to come in and start value engineering and changing scope on the project. So really, to our mind, it was very much more of a develop and construct form of contract rather than a true design and build. Ourselves and Capita Simmons, the structural engineer, were novated across. Hawley remained client side, but then had a separate role working with the M&E subcontractor, supporting them in the delivery of the project. A few facts and figures there. The original pre-tender estimate was about £6.5 million, and the final construction ended up coming in at about 4.7 million. That was really an indication of the market that we were in at the time, and that was the final construction figure for the fabric and the interior of the building, which has actually worked out at a very competitive cost per square metre. During that process, we finally interviewed two contractors. Wilmot Dixon just nudged it really on the sustainability credentials, and they ended up being the contractor that built the project. That's just a sample of the level of information we sent out to tender. Really, it was about trying to define the things that really matter to us, the edge details, the elements that you see, the specification of key components, but actually still allowing the contractor to develop some of the detail further on down the process. I don't think I've ever had a project with so many site visits throughout the course of the project. We had numerous visits, understandably, for the architecture and planning students and the technology students and the environmental engineering students. We had the ROBA present at the time, Sanad, come round as well. We had a number of our own students coming around, a lot of them ex-UE students in their own right. And then with Wilmot Dixon, we took Sainsbury's around, looking at opportunities that we could deliver with Sainsbury's in terms of looking at the straw bale cladding and the low carbon options, and the same with M&S, looking at the low carbon stores with M&S. So Measurement, just briefly on measurement, I mentioned earlier we undertook the BREEAM assessment. We have our own BREEAM assessors in-house, which helped in the process, but as is always the case with BREEAM, there are issues associated with that. We had a score of 75% at pre-assessment stage. We ended up with a final score that was actually at about just shy of 72%. Credits were lost, credits were gained. Again, part of the process really, but again, it was a particularly onerous thing to really try and achieve that excellent. A number of elements, although the building's fully naturally ventilated, because this room here doesn't have windows, it doesn't count as a naturally ventilated room, despite the fact we have the ground ventilated system. So we lost our credits on natural ventilation. So again, BREEAM has a very, very specific way of assessing credits, and that has implications. The boiler for the building's using recycled chip fat from the university campus, and again, BREEAM initially were not willing to accept that as a possible renewable source, and it took an awful lot of conversation with us and the BREEAM advisors to convince them otherwise. The RAP finally achieved the 22% that we mentioned. There's just some photos here. I'll just flick through these very quickly because we're running short on time, and we'll see these when we go around on the tour in a moment. And some of the building in use there. And then just finish really with some commercial office case studies. I just wanted to really show in terms of some of the learning that's sort of going across our business. At StrideTreglown, we have a number of different, we cover pretty much every sector that exists. I'm part of the education team, but our commercial team and our healthcare teams all relate back to one another and all communicate with one another. And so we have shared learning with green groups existing through the business. One Glass Wharf is a building down at Temple Quay in Bristol that we completed relatively recently. Burgess Salmon are now the occupant in there. That achieved a BREEAM Excellent. Again, not an insurmountable task, particularly regarding some of the cooling requirements associated with this building. And this actually uses the cooling from the river to help cool the building as well. Babington Road, some of you in here may know this building. South Gloss offices that we completed probably about 6 months or so ago. Again, another BREEAM Excellent building, utilises a number of different technologies, and that achieved a BREEAM Excellent. Number 1 College Square, which is down by at Bristol, the first phase of that actually only achieved a BREEAM Very Good. What we're finding is that the BREEAM requirements are really being driven by the agents looking at the letting opportunities that really in the commercial office sector, if you haven't got an excellent, unless you've got a pre-let, then chances are it isn't really worth going to market with that. So that's starting to push up the sort of the boundaries in that respect. So the first phase achieved BREEAM Very Good, but the second phase, which is just about to start on site, the agents realised they need to start pushing that up higher, so we're now looking at moving that to BREEAM Excellent. Just finishing really with our own offices. In Cardiff, we thought we'd put our money where our mouth was and find a site and build our own office building, which has achieved a BREEAM Outstanding. Design stage, it achieved the highest BREEAM score to date, which was 89.12%. It's received a number of awards. It's currently going through the post-completion assessment, and our staff have now moved into that office as well. That's using a number of different technologies and a number of different finishes within the facade, including a brown roof up on the top there. And we're currently looking into using PVs on the roof as well to achieve zero carbon. And again, what does zero carbon mean? Well, for us on this particular building, it means zero energy coming into the building. So the feed-in tariffs are allowing us to balance the investment costs for the PVs. So we're looking at a payback period of about 7 to 8 years on the PVs that we're putting onto that roof, and that's costing us in the region of about £50,000 to put those PVs on there. We also have a biomass boiler as well as a number of other technologies, as well as a remarkable low air tightness result as well. So a number of things are combining there. And just to finish really on some future thoughts, really, clearly there's so many different approaches. What is low carbon? I'm sure is going to be discussed this afternoon. But in terms of the assessments, how do we measure it is such a big issue. And how obsessed do we become with that measurement process? Is it BREEAM? Is it using the IES model? Is it getting an EPC, a DEC, using the RAP system? Does it tie into our CRC? who knows? Design approach for us, the key thing is keeping it simple, trying to reduce that reliance on complicated systems, but where the opportunity arises, to test out new ideas in small-scale opportunities, really. And then the last thing, really, is that complexity and uncertainty from the current political and financial climate. We're seeing it more and more, particularly with the new schools projects going forward as well. Now that the lovely Michael Gove has put a halt to just about everything going on in schools design, the agenda seems to have changed, and sustainability isn't quite where it was at the top of the pile and slowly seems to be dropping a little bit down below the radar. And with 40% reduction in build costs as are being discussed at the moment, one questions where carbon and BREEAM and environmental assessments are going in that respect. So it's what we can do on that lower budget. So that pretty much concludes it, almost bang on time.